This is Algebra 2 with Trig. Working on section 13.4. We're going to evaluate the inverse functions. We're doing this with the unit circle. A few things we want to think about is, where is sign positive? If we think about the unit circle, sign is positive wherever you're above the x-axis. Sign is positive in both the first and the second quadrant. That's where sign is positive. Sign is negative below the x-axis. And that's just how you graph any point. You do your x, and then you do your y. And if the second number is a positive, you go up. If the second number is a negative, you go down. Where is cosine positive or negative? Well, as we think about graphing out any point, cosine are the x values. So cosine is going to be negative when you go to the left. It's going to be positive when you go to the right. Even in these quadrants, it would still be positive in the fourth quadrant because you're going to the right from the origin. And down in the third quadrant, cosine would also be negative. Now, tangent's a little bit more complicated thinking. Tangent, we have to use y over x. Calculate tangent. Tangent of theta equals y divided by x. So if we know that this quadrant is plus plus, and this one is minus plus, and this is minus minus, and this is plus minus, tangent is going to be positive, of course, in the first quadrant, because you have your fraction plus over plus. A positive y value divided by a positive x value gives you a positive tangent. But in the second quadrant, tangent would be negative, not -1. That's not what I was trying to imply there, but it's going to be negative. Tangent is negative in the second quadrant because your signs are negative and a positive. So when you divide y divided by x, a plus divided by a minus, you get a negative answer. So tangent's negative. Here, tangent's going to be positive in the third quadrant, and tangent's going to be negative in the fourth quadrant. So one easy way for us to kind of remember all this, what we have talked about before, is all students take calculus. All of them are positive in the first quadrant. Sine is the only one positive in the second quadrant. Tangent is the only one positive in the third quadrant. And cosine is the only one positive in the fourth quadrant. So if we're going to connect some quadrants, we could use to restrict the domain of each trig function. What we're trying to identify is, where do we have a positive and a negative? So for sine, we have a positive in the first quadrant, and we have a negative in the second quadrant. We're positive in the first and negative in the fourth. We're not positive in the first and negative in the second, right? So we can't have a continuous measurement. So that's why we decided to look at the first and the fourth, because we can look at angle values continuously through this range, and we get positive y values and negative y values. For cosine, we get positive y values in the first quadrant, but cosine also gives us negative. So we have plus here and minus there. We have plus here and minus there. So cosine, when we restrict the domain, and we're not going to look everywhere, we are looking at values that are falling from 0 up to 180, because that would cover all the cosines that are positive and all the cosines that are negative. And then tangent. Tangent is positive in the first quadrant, like we've talked about, and negative in the fourth quadrant. Now, somebody out there might point out, well, isn't tangent negative in the second quadrant? Well, yes, it is. It's negative in the first, and it's negative in the second also. So why don't we connect those two? Why are we connecting these two? And the reason why comes back to this undefined. Where is tangent undefined? Tangent is undefined where you're dividing by a 0. So if your coordinate is 0 right and left and 1 up, we have 0, 1. So your tangent is undefined at 90 degrees. So if we were to connect them and make your shaded in region be across the top, we'd have an area in between, we'd have an angle in between that we'd have to jump over, that you wouldn't include. So it's undefined at the top, it's undefined here at the bottom, which we're actually going to call a negative 90 and a positive 90. A negative pi over 2 and a positive pi over 2. That's the value of angles that we're going to look at for tangent. That's the value we're going to look at for sine. For cosine, we're going to look at values from 0 up to 180. So that means when you go to your calculator, it is only going to give you answers between positive 90 and negative 90. Your calculator for sine will not give you an answer that's obtuse. That's why with the law of sines we talked about, you could not solve for an obtuse angle. Cosine can solve for an obtuse angle. It's the only one, because it comes over here to where obtuse angles would be. But sine does not. And we don't use tangent to solve for angles, so we don't have to worry about that. So that's what this chart down here is trying to indicate to us. It's trying to show us that when we do the inverse of sine, all of our answers are going to fall between pi and negative, or pi over 2, sorry, and negative pi over 2, 90 and negative 90. Don't call this 270 down here, because you're not really going around to get to it. You're cutting down to get to it. You're going in the negative direction. Where cosine goes from 0 to 180, right here, which can be talked about in radian, is 0 to pi. And tangent is also from negative 90 to 90. So what we notice is that sine and tangent, notice that for sine and tangent, a negative value implies a negative angle. So if we have a negative sine of a negative value, that's going to give us a negative angle. We can convert that to a positive angle, but that's going to give us a negative result because we're down here in this below the x-axis zone. Okay. Then for cosine, when we get a negative value, that puts us in the second quadrant which actually gives us an obtuse angle. That will give us 120, 150, 132. You can calculate an obtuse angle. So now let's start coming over here and thinking about what is the inverse? What does inverse mean? When asked to evaluate inverse functions, think about what angle would give you that value. So sine inverse of -1. What angle, where is the angle that you get -1 for sine? Well, sine is a y value. So again, I like to draw the pictures so it gives us the visual. Where is sine? Where is the y value? -1. Well, down here we get 0, -1. It's the only location. So coming straight down. Some people might call that 270. But to be correct, we should use the terminology -90 or -pi/2. You can test that theory by going to your calculator. You could do sine inverse of -1, and it should give us -90. It's not going to give you 270 because the calculator knows what these limited domains for the angles are. So you can only go up to 90 and down to -90. That would be the appropriate way to label the angle where sine is -1. You do not need your calculator to answer any of these questions. Cosine inverse. Where is cosine -√2/2? Does any of that mean anything to you? Well, √2/2, that sounds like that's the 45 type angles, right? So when you draw out your practice circle, call it a unit circle, where is cosine negative? Well, cosine is only in these two quadrants. So we're only going to look in those two quadrants. It would be positive in the first quadrant and it's negative in the second quadrant. So I'm expecting my -√2/2 to be in our second quadrant. I know my coordinates in this direction are -√2/2 and √2/2. Where is that happening at? That's happening at this angle of 1/4, 2/4, 3/4, 3π/4, or some of you like to refer to the term as 135. We're looking for both degrees and radians for these answers. Now, the toughest type of these is when you think about tangent. Where is tangent √3/3? Well, when we look at our unit circle, we don't see √3/3 on this sheet at all. You can find where cosine is -√2/2. You can find where sine is -1/2. But you can't find where tangent is √3/2 or √3/3. We don't typically write it on a unit circle. There is no reason why you couldn't put it off to the side near your coordinate. But let's think about it. Doesn't mean we can't get it just because we don't absolutely know. we know that tangent is going to be in the first or the fourth quadrant. That was the rules that we talked about where tangent can give you an angle for it. Well, this is positive. So I know I have to be in the first quadrant because tangent is positive in the first and negative in the fourth. Now, tangent is 1 when we're at 45. We don't want 1. We want root 3 over 3. So root 3 over 3 is going to happen down here at 30 degrees, or it's going to happen up here at 60 degrees. All right, and we just have to try to look to help us figure out which that's going to be. So if we want to try the 31st, so I like to draw in my triangle. It's pretty clear. You can see what side is a long side, what side is a short side. So your long is root 3 over 2. Your short is 1/2. Root 3 over 2 is kind of like root 3 over 3, but it's different. It's not the same thing. That's the cosine. That's the tangent. So tangent, you have to take the y value and divide it by the x value. So right now, I'm verifying if this is the answer or not. Am I going to get root 3 over 3? So to do that, I have to multiply by the reciprocal. So I take my denominator and I flip the guy to multiply the top. I flip the denominator, and that reduces the 2's out. And that gives us 1 over root 3. And when you rationalize the denominator, that means we do root 3 over root 3. That gives us root 3 over 3. So yes, at this angle of pi over 6 or 30 degrees, I did have a tangent of root 3 over 3. So that could be a good way for you to remember all 30-degree reference angles have a root 3 over 3. It has the 3, like 30, root 3 over 3. Unfortunately, it's not like a 6 because it's pi over 6 is a radian, right? So then you start to play all these games with numbers. But root 3 over 3 for tangent's going to happen at any reference angle of 30 degrees. That's going to happen at 30, at calculate would happen at 150, at 210, and at 330. You're going to get the same tangent. This one is the only correct one because it falls within the range of 90 and negative 90. So you go ahead and try these 3. If you're watching the video, you can pause your video, work on the problems, and come back and check it out. All right, to check out what we have, we're looking only in this first and fourth quadrant, where sine would be negative 1/2. That means sine is coming down a short distance. So of course, a short distance for y means that your triangle is going to have a long x and a short y. So that would have to be the coordinates of the angle. That's what you have to figure out. Where is this y value, negative 1/2? And now you've got to think about where that is. And if you're really good at the unit circle, you know that that is 11 pi over 6. That's 11 pi over 6 over here. Y is negative 1/2. But that's not really the appropriate notation. We've got to come down that pi over 6. Instead of going up 30, we're going to go down 30. So we're going to say negative pi over 6 or negative 30. Cosine is 1/2. Cosine is your x value. So cosine is your x value, and there's your 1/2. That's half of the x. Then when you go straight up, you can start to see that triangle form. You clearly have a small edge and a long edge, short and a long. So your x is short and your y is the long side. So that's the coordinate that would be right up here. So that's where your cosine, when we talk about these two quadrants, that's your cosine is 1/2 at 60 degrees, or pi over 3. You can verify that by looking at your unit circle. The only spot in these top two quadrants where the x value is 1/2 is right there at 60 degrees, pi over 3. Yes, it is also 1/2 down here, but we don't look into the fourth quadrant when we do cosine. We only look into the top range. Tangent is -1. Well, tangent only looks in these two quadrants. I know that all the terms are positive in the first one, so that must not be it. So it must be down here. And I think about what my coordinates would be. -1/2 divided by √3/2 should be -√3/3. Oh, √2/2 and √2/2. If I had an angle that was coming down here at a -45, I would be down here at √2/2, -√2/2. So when I calculate out my y over x, and if you still need to flip the guy and multiply, you can go ahead and see that they all cross out. So you still have your -1. So that happens at -45 or pi over 4. So on the flip side, we're going to evaluate. It's really just more the same question. There's a few things in here that gets us to think a little deeper. Beware of values outside the range. Remember, our values for sine and cosine were between -1 and 1. Sine and cosine, the x values can only go out to the edge of the circle. So your x values can only get as big as 1 because nothing else for the x value is bigger than here. No y value is bigger than here. So all your answers are smaller than 1. When you do that, though, you can get tangent values that are bigger than 1, though, right? Because you can do your y divided by your x. If your y value is big and your x value is small, you can actually, I guess that'd be the other way around. You could get values that were greater than 1. And also, if you think about the reciprocals, those could also be values bigger than 1. Okay, so where is cosine √3/2? Why don't you guys work through G, H, and I, since they're pretty much the same questions that we've been talking about, and then pause the video and come back once you've worked those out. When we look here, we're looking at what angle, that's what the -1 means, what angle, that's the inverse, cosine inverse, what angle has an x value, has a cosine of -√3/2? Well, cosine, we only look in the first two quadrants. So if I need to, I could pull out my unit circle and I'm looking for x values that are negative root 3 over 2. That's positive root 3 over 2. Oh, there's negative root 3 over 2. So negative root 3 over 2, that's the long side. So if you think about the long comes way out, and then you go up half. So that's how you would know that you're way out there. That is your negative root 3 over 2, positive 1/2. That's your coordinates. So that's at 150, or you could also call that, it's over 6, right? So it's 5 pi over 6. Now this next one, we're looking for root 2. We typically would only look for answers in the first and fourth quadrant for sine. We're looking for root 2, and we think that, well, that's kind of weird because root 2 is not one of our values that we typically get. We get root 2 over 2. But where would root 2 be? Think about what that means. If root 2 has a y value that's up this much, that's root 2 over 2. So the root 2 has to be twice that amount. It has to be way up here. It has to be twice the root 2 divided by 2. Well, there are no coordinates up here. That's like outside the unit circle. That's more than 1. Y cannot be more than 1. Only tangent can be more than 1. And also cotangent, cosecant, and secant can be more than 1. Sine and cosine have to be from -1 to 1. We have no solution, or no real solution. Tangent of negative root 3. We're doing tangent inverse of negative root 3. Well, tangent, we look in these two quadrants. All right, if you remember how we learned it earlier, we talked about how 30 degrees had the root 3 over 3. So now that's gonna help me think about, I'm gonna try this angle down here this time. I'm gonna try the fourth quadrant because that's where tangent is negative. Right? It's negative down there, so I'm not going to look at the top one. My coordinates are half and negative root 3 over 2. And I'm going to test this out if I'm not confident about it. So that means I take my root 3 over 2 and I times it by 2 over 1. I flip the guy and multiply, and that crosses the 2's out. And that gives me negative root 3. Oh my goodness, that was the angle. What is that angle? If you're not certain, you can look at your unit circle and you get the answer of 300 and 5 pi over 3. Wait a minute, I can't give an answer of 300. Oh, I'm going to give like that reference angle. I'm going to give this angle in here. It's going to be a negative. So how far is that? That is 60 degrees down. 30, 45, 60. So actually, the best answer for this is to call it negative 60 degrees or negative pi over 3. It's not appropriate to call those values 300. Okay, because you're not doing your measurement all the way around. You're doing your measurement from the 0 going straight down. Okay? Now we're moving into some spots that we can use our calculator for. Having your calculator will help you be able to calculate these quickly, and we're going to jump between radians and degrees when we answer these questions, all rounded to the nearest hundredth. So what we're trying to do, I imagine I'm in degrees, so there I am in degrees. So my answer here, when I do sine inverse, that's a little -1 of 0.42. What that's asking, what does that even mean? These are your y values. That is asking for a y value at not at 0.5, but actually at 0.42. So you come over here to see where it intersects. And what is that angle that is formed? What is 0.42 up? That's what this is asking. You're up 0.42. That's a 24-degree angle. 24.83 degrees. And if you wanted to know what that was in radian, you would go to mode, go down to radian, and then you can just hit enter again, and it'll recalculate it using the current menu of radian, and that gives us 0.43 radian. And it's important for us to write the word radian, because we're usually not considering radian not to be with pi and things like that. So what does 0.43 radian mean? I don't get it. What does that even mean? Well, 1 radian is the length of the radius going around the circle. That's 1 radian. That's about 57 degrees. So this apparently is less than 57 degrees, it's 24. It's more than half that less. So that's why we have more than less than half. Is that a word? 0.43. That's why we're less than half on your radian. You don't have to totally understand and be able to explain all that, but there is a reason, there is an understanding for what that 0.43 radian means and how that is a reasonable answer. Okay, now we have tangent. Where is tangent? Tangent's always a tough one to draw because you're doing a fraction of y over x, and where y over x gives you numbers. So you really just need your calculator. So you're doing tangent inverse of -1.7. Okay, remember we're in radian right now. So our answer is in radian. So we get -1.04. -1.04 radian. How do I know it's a negative answer? Because your tangent is a negative number. That -1.7 is going to put you in the negative area. So you're going down more than 57 degrees. You see that? 1 radian is about 57.2 degrees. So this is more than that. So let's switch it over to degree mode. And when you recalculate that, there's an answer that is more than 57 degrees. Or is it less than 57 degrees? However you want to say that. -59.53 degrees. And then you have your cosine inverse. Okay, this one we can explain a little bit easier than we can with tangent. Cosine of -0.8. Well, negative is to the left. 0.8 would be like out here somewhere, right? And if you come up, you're trying to figure out where that angle is. What that angle is. Well, cosine will tell you. Cosine inverse of -0.83. And we get a 146-degree angle. 146.10 degrees, or we can turn that into radian. And you hit enter again, and now it calculates it in radian, which is 2.55 radian. Okay, that would be over 2 radiuses along the path, the circumference. All right. So those were some pretty straightforward inverse questions. Now we come down to our final 4, and you've got 3 that you can try, but we've got our final 4. Now this is funny. They're asking for angles from 270 to 360 for cosine. They're asking for angles between 180 and 270. So this is going to be different than what the calculator is going to give us. So then we're going to have to calculate where that is. Let's give it a try. So we're going to do, where is cosine? 0.4. Well, cosine are your x values. Cosine is a 0.4 is approximately right there. So cosine have x values up here. Typically, that's what we talk about, right? We typically talk about cosine answers land in here. So if we want to figure out, we'll get ourselves in degree mode so we're more comfortable. Cosine inverse of 0.4, and it's going to give us a 66-degree angle, 66.42. So cosine inverse of 0.4 equals 66.42. But they don't want 66.42. They want an answer in the 4th quadrant. They want an answer that actually would be down here. That is also a cosine of 0.4. So we draw it from the origin. So we need to come all the way around and tuck in there. Well, how do we do that measurement? What we look at is the reference angle. That reference angle right there, really important to us. So if this angle is 66 there, this angle down here is 66. So we're going to take 360 and subtract this 66.42. 360 minus our current answer, because we only want to round our final answer, and we get 293.58. 293.58 degrees. If you take that number, that's the angle, and you do cosine of that answer, of that angle, you'll get exactly 0.4. You can check your answer. It's kind of cool. All right, where is tangent 2.1? Tangents are tough to draw because, again, it's that fraction thing, and where's a fraction? But what you're looking at is tangent is typically in the 1st and 4th quadrant. We're looking for an answer that's over here. Where is tangent inverse of 2.1? That happens at a 64.54 degree. Tangent inverse of 2.1 is 64.54 degrees. Now we want to get over here into the 3rd quadrant. That's the only other place where tangent is positive. It's the only other place. So for us, we need to look at this reference angle right there. That's a 64-degree angle. So we're going to go all the way to the 180, and we are going to go that same reference angle, apparently past 180. So we're going to take 180 and add it to the 64. So we add 180 to this, and we get 244.54 degrees. And you can test that answer by saying tangent of your answer, and I better get exactly 2.1. Bingo. So now I'm down here for the sine. The sine are your y values that are negative 0.23. That's down here. All right. And typically they want answers that are between, okay, they could have asked it for over here in the third quadrant, but no, they're asking for it in the fourth quadrant. So when I do sine inverse of my negative 2.2, whatever, my negative 0.23, I get negative 13 degrees. Oh, I see the weirdness going on. Sine inverse of negative 0.23 gives me a negative 13 degrees. Negative 13.3 to be exact. So my reference angle is 13.3. I'm going to take my 360 and subtract my 13.3. So you could say adding if you like. So that's going to be 346. 346.7 degrees. And if you want to test that, you say sine of your previous answer, you better get negative 0.23. Boom. Worked out brilliantly. Cosine of 3/4. Cosine is 3/4 way out here. So your calculator is going to give you this answer that's right there. Cosine inverse of 3 divided by 4. That happens at a 41-degree angle. So cosine inverse of 3/4 is a 41.41 degree angle. But they want us to give an answer down here in the fourth quadrant. So my reference angle is 41 degrees. So that's 360, not counting my 41. So 360 minus my answer. That gives me a 318.59 degrees. And you can test that because it's cosine of your angle, and you get 0.75, which is 3/4. All right, good job. You can pause the video and try your last three on your own. Now we look at the last few questions. Here we have the tangent. Typically with tangent, we look in the first and fourth quadrant, but it wants us to have an answer down here in the third quadrant. So we're going to take our calculator and do tangent inverse of 4.7. That gives us a 77.99. So that would be up here somewhere. For us to get into the fourth or the third quadrant between 180 and 270, we would need to add 180 degrees to that. Think about it as your reference angle. Your reference angle is 77 degrees. You're going to take from the 180 and go 77 degrees into the third quadrant. So what that comes out to be is just adding 180 to this. And that gives us 257.99 degrees. And if you want to test that, you can do the tangent of that value, and we better get 4.7. We want a sine of 6.2. Sine is our y values. Where is y 0.62, so over half the distance. So that would be something equivalent to over here. But we also want an answer that's over here. So we can get this answer because the calculator gives us answers in the shaded region. Sine inverse of 0.62 gives us 38.32 degrees. But they're asking for an answer in the second quadrant between 90 and 180. That's another location where sine is a positive value, and it can be 0.62. So what we're going to do is this reference angle is our 38 degrees. We're going to use that reference angle here and subtract backwards from 180. We do 180 and we back up that same reference angle. So 180 minus 38.32. So 180 minus the previous answer. That gives us 141. And we can test that answer by saying sine of our answer, and we better get 0.62. All right, last one. Pause it if you think you have a good idea on how to do this, if you haven't already. Cosine is negative 0.39. So cosine are x values. So we go in the negative direction. This is what it looks like. You don't really need these drawings, but it can help. Negative 0.3 is approximately here, 0.39. So that happens here, and that also happens here. If we use the calculator, we're going to get this answer like so. Cosine inverse of negative 0.39, we're going to get a 112 degree angle. So cosine inverse of negative 0.39 is 112 degrees, 0.95. Now the other location that has that is down here, which would be 112 degrees from there. Now you can do this two different ways. You can figure out what your reference angle would be, subtracting 180, getting your reference angle, adding it to 180, that would totally work. But if you want to use the 112, that is backing up from the 360, that same amount. So 360 minus, that is 247, and that is between 180 and 270. 247.05 degrees. And we can test cosine. Now you can't put in your rounded number, but you can put in the exact number, and I would expect to get negative 0.39. Voila. All right. Hope all's good.